So in this video we are going to look at how some organic compounds are synthesized in the laboratory. We are going to look at the methods of preparation of carboxylic acids, methods of preparation of esters, and also how amides are synthesized in the laboratory by chemical equations. Kindly like and subscribe to the channel so that you will keep in touch in every update that drops on this channel. Let's begin with the methods of synthesis of carboxylic acids. So carboxylic acid is basically an organic compound that is composed of the carboxylate functionality. So this functional group is a carboxylate functional group, a carbonyl group bonded to an acyl portion, and a hydroxy. So the carbonyl carbon is bonded to an acyl, so this one can be an acyl or an allyl group, and an hydroxy. So whenever this functional group occurs in an organic compounds, that compound qualifies to be a carboxylic acid. So let's go straight to how carboxylic acids are synthesized in laboratory by chemical equations. The first method for carboxylic acid synthesis is the reaction between an acyl trihalide and a base. So an alkaline hydrolysis of an acyl trihalide tends to yield a carboxylic acid. So acyl trihalide, this one is, let's say, hydrocarbon changes an alkene whose one carbon, the hydrogens on one carbon has been replaced by a halogen. So treating an acyl trihalide, so this one is an acyl trichloride or any other halogen with a strong base in an aqueous solution would yield a carboxylic acid in the laboratory. Next, when you have a Grignard reagent, so a magnesium chloride bonded to an acyl group is a Grignard reagent which was named after the scientist who discovered it. And you add a carbon dioxide in water to it, that reaction also yields a carboxylic acid. So this reaction is called a carbonation of Grignard reagent. So you carbonate a Grignard reagent, then you hydrolyze an acid. Carbonation followed by acid hydrolysis of Grignard reagent also yields carboxylic acid in the laboratory. The next one is an acyl chloride. This one is a derivative of carboxylic acid. When you hydrolyze an acyl chloride in an acid, this reaction goes profusely. When you just do acid hydrolysis of acyl chloride, they just get you the carboxylic acid straightforward. The same thing an ester, which is also a derivative of carboxylic acid. When you hydrolyze in an acid, you are going to get a carboxylic acid. When you have a dicarboxylic acid, that is a group with two carboxylic acid functional groups, then you heat it, you tend to decarboxylate it. So this reaction is a decarboxylation reaction whereby heating of a dicarboxylic acid releases a carbon dioxide and gives off a carboxylic acid. Also nitrile, when you hydrolyze nitriles, it yields carboxylic acids. When you do profuse oxidation of aldehydes or even alcohols, whether aldehyde or alcohol, you oxidize it in hot potassium permanganate. This oxidative reaction yields carboxylic acid. It is only primary alcohols that yields carboxylic acid in this reaction. Also, when you have an oxidation of this ethane in this strong oxidizing agent, it also yields a carboxylic acid. The last two is ozonolysis of unsaturated hydrocarbons. So this one is a hydrocarbon unsaturated. When you subject to ozonolysis an ozone, there is a possible cleavage. and that leads to carboxylic acid formation. Let's look at esters. Esters are reactions or compounds synthesized from carboxylic acid and alcohol. And this is their functional group, a carbonyl with an alcohol group. So this is an example of an ester, ethyl acetate. A carboxylic acid portion and an alcohol portion is an ester. The primary method for ester synthesis is a reaction between a carboxylic acid and an alcohol in an acid. So, esterification reaction between carboxylic acid and an alcohol using this strong acid, sulfuric acid as a catalyst, yields an ester. Similarly, we have an anhydride and you subject it to an alcohol. There is a release of a carboxylic acid and ester is produced at the end. So this is an alcohol subjected to anhydride. This reaction releases of carboxylic acid by mechanism and gives off an ester. Once again, if you have an ethyl chloride and you add an alcohol, just similar to this, because these ones are all derivatives of carboxylic acids, it gives off an ester. So an alcohol plus an ethyl chloride gives off an ester. A silver carboxylate subjected to an iodine in carbon tetrachloride is also a strong method of synthesizing ester in the laboratory. So a silver carboxylate in an iodine solution of carbon tetrachloride gives off an ester in the laboratory. The next reaction is what we call a Treschenko reaction, which involves the disproportionation of two aldehydes in an alcohol-side. So an aluminum trihydroxide yields an ester. So two aldehydes or the same aldehydes of 2 moles in an alcohol-side ion tends to yield an ester. Finally, we have a ketone in peroxy acid. That reaction also yields an ester. There is a possible cleavage of the carbon-carbon single bond between the carbonyl carbon and the adjacent carbon, and there's an insertion of an oxygen from the peroxy acid, and that releases an ester. So this is a possible means by which esters are synthesized in the laboratory. Amides are groups containing an amino group bonded to a carbonyl group. In the laboratory, they are synthesized by a reaction between ammonia and an ethyl chloride, which releases HCl to get an amide, or a reaction between an ester and an ammonia, which gives off an alcohol to give an amide, or a reaction between a nitrile and an alkaline hydrolysis partially. So partial alkaline hydrolysis of nitriles gives off an amide. Partial because complete hydrolysis of this one gives a a carboxylic acid. So partial hydrolysis of nitrile gives off an amide. Once again, when you have a carboxylic acid solution and you add an ammonia, you are going to get this complex in the solution. So an association between the carboxylate ion and the ammonium ion because of their negative and positive charges, or the acid and base substances. When you have this mixture and you heat it, there's going to be a release of water, 2 hydrogens from this ammonium, and the other oxygen of this forms water, and the resulting compound is going to be an amide. So basically, that's how these possible organic compounds are synthesized. They are very simple. Kindly like and subscribe to the channel, as you are going to drop more videos on some organic compounds